Welcome to the chemistry class, and then today we're going to solve this problem. It's a pH related problem, and then what we're given: concentration, aqueous solution, and then the product. So the product is salt. The pH there is 7, so which means that salt should be in the environment of neutrality. So we have lithium bromide, magnesium perchloride, this is ammonium perchloride. So that is it. So we look at what we have in hand, and then determine the previous reactions, or you determine the forward reaction. So looking there, the product, we have bromine, lithium, and then making a salt. So what we have acid, base to give you salt, and water. So those are the combinations if they're in aqueous form, and we need, for neutrality, we need strong acid. So if the acid is strong, and then we also have a strong base, so in this case we need a strong base. So if a strong acid and strong base, then it's gonna have a balance. So that balance is a neutrality that we call, and then we expect a pH of roughly 7.0, for neutrality. And then let's go further. Find that neutrality will give us a pH that is 7.0. And then from there, what we do, we look at what we have. Let's taste one by one. We have sodium sulfate. If it was sulfide, it's not sulfate, sulfide. So sodium hydroxide is a strong base, and then sulfurous acid is a weak acid. So in that case, this solution is going to be basic, not neutral. So we try another one. We try sodium perchloride. So that one there, it should be formed from sodium hydroxide, ammonium hydroxide. So ammonium hydroxide, that will be ammonium hydroxide with that is just, we picked up that it's weak, so sodium hydroxide is weak. In this case, it's not gonna work. So the next one would be perchlorate, perchloric acid. Perchloric acid is a strong acid. Let us do the calculation there. So meaning that we have perchloric acid, that is H chlorine and then 4 atoms of oxygen, plus that will be magnesium hydroxide. Okay, so magnesium hydroxide in this case is a strong base, and perchloric acid is also a strong acid. So in that case, gives us it gives us magnesium perchlorate. So that will mean that we have a salt, then plus water, beside even balanced, but I think it's balanced. And then we have magnesium perchlorate. So that means that one there is a perchloric acid, is a strong acid, and that one is also a strong base, and then that should give us a neutrality. So that is, I think in that case it passes, So going back there, we know that magnesium perchlorate is part of the solution that would be neutral. So that one there is correct. And they said only. Is that only? Let us check. That one there, sodium sulfite already failed because we tried that previously. So we'll have to have lithium. So lithium hydroxide. So that's a base, and it's a strong base in that case. Plus bromic acid. And then hydrobromic acid to give us lithium bromide, which is in this case salt plus water. So we assume they're all in aqueous solution. except the water could be in liquid. So that is strong base, and then that one also will be strong acid. So in this case it will bring neutrality, and then that means it's neutral. So when it's neutral, we expect a pH of 7. So going back to our options there, we see that that one there is a strong lithium bromide. Is a strong I can say it's formed from the strong acid and strong base. But the sodium sulfate, no, as we tried that in our first option. So answer should be magnesium perchlorate. That's the first answer we found. And then the second answer, we did find out that lithium bromide is salt formed from strong acid and strong base. So we have two options. So coming back to the options that we took, I think that was the correct option. So we still need to know like which problem. This one there, it's correct. That one there is a correct option. So thank you very much. See you on the next lesson.